Hey guys, welcome to your video tonight over division properties of exponents. So what we've learned so far, let's review. We've done 7-1, which was integer exponents. 7-2, we went over scientific notation briefly. 7-3 was all of our multiplication properties of exponents, and now we're doing 7-4 division properties. So make sure you have out your foldable so that you can fill these in exactly as we did with the multiplication properties. You're going to have your explanation written in words on the left-hand side, and then, or I guess since we're now filling out the right-hand side of our foldable, your words are going to be written on the right-hand flap, and your exponents are going to be written in that, or your examples are going to be in that middle section, exactly as we did the multiplication. So let's learn about 3 new properties of division today. To get started, our first property is the quotient of powers property. A quotient of powers, remember, this is only when two things have the exact same base. This only works when the base is the same. We can find a quotient of powers by writing the powers in a factored form and then dividing out all the common factors. So if you take 3 to the 5th divided by the 3 to the 3rd, as you can see here, we have that 3 to the 5th is 5 3s, 3 to the 3rd is 3 3s. Well, 3 divided by 3 is 1. So these 3's here are canceling. I can get rid of those because they're in common. They make 1s when divided, 3 divided by 3. And I'm left with 2 3's at the top. Okay? Same thing, if I take 4 to the 6th power divided by 4 squared, I have 6 4's up top and only 2 4's down below. Well, when I cancel out my common factors, what am I left with? 4 4's on the top. What relationship do you notice between the given problem and the answer? Exactly. All you're going to do here is keep the base and subtract the exponents. 6 minus 2 is 4. If I look back at this example, 5 minus 3 is 2. So this is the exact opposite of multiplication. Multiplication, we kept the base and added the exponents. Here with division, we're going to keep the base and subtract the exponents. So I would pause the video and write that in your own words in your foldable. All right, here are the examples that you're going to write. First example, 2 to the 7th divided by 2 squared. This is the same base of 2, so I keep my base of 2, and I'm going to subtract my exponents, which is going to give me 2 to the 5th power, which many of you know is 32. All right, next example. Let's jump over here to this 88x to the 5th y to the 4th, divided by negative 22x squared y to the 3rd. First thing I'm going to do is I'm going to divide out these factors right here. The 88 divided by negative 22. That right there, that's just normal division, guys. That has nothing to do with exponents. That's just normal division. I get negative 4 from that. Now I'm going to take my x's right here, and I'm going to keep my base of x, and I'm going to subtract those exponents, 5 minus 2. Then I'm going to take my other base, which is y, and I'm going to subtract those exponents, 4 minus 3. Then lastly, I'm going to figure out what my simplified answer would be. Negative 4 x to the 3rd times y. That's y to the 1st power, which we know is just y. All right, next example. D to the 4th, e to the 3rd. Nothing in the numerator I need to simplify right now, so I'm just going to rewrite it. Now this denominator here, I noticed that this involves a multiplication property that I learned. Okay, this property is, I need to give the 2 exponent to everything that's in my parentheses. So the d is now going to be squared, and my e is squared. That squared on the outside applies to both the d and the e. Now that I've taken care of that multiplication property first, now I'm going to finish with my division property. So I keep my base of d, and I'm going to subtract my exponents, 4 minus 2. Next to that, I'm going to have my e with 3 minus 2. When I simplify that, I get d squared times e as my answer. Okay, let's look at the next example. This one is similar to the last one in that my numerator I'm not going to do anything with right now. There's no simplifying that needs to take place. In my denominator, I have a power to a power. When that occurs, I multiply my exponents. So I get m to the 10th times n. Now I'm going to finish this. I keep my base of m, and I'm going to subtract the exponents, 5 minus 10. Then I'm going to take the n and subtract those, 4 minus 1. Remember, this 1, the n has an exponent of 1. When I simplify this, I get m to the negative fifth n to the third. What do we know from 7-1, integer exponents? You cannot have a negative exponent in your answer. So I need to simplify this, clean this up a little bit. The n to the third can definitely stay in the numerator, but by m to the negative fifth must move down to the denominator so it can become m to the negative, or m to the positive fifth in the denominator of my fraction. So that would be my answer. Next property, positive power of a quotient property. This is when you have a quotient raised to a positive power. What we need to do here is we need to make sure that both the numerator and the denominator of the quotient receive that power of 4. Okay? So 3 fifths to the fourth power is 3 fifths times 3 fifths times 3 fifths times 3 fifths. You have 4 of those, which is the same thing as 3 fours and 4 fives. Okay, so this is kind of like how we talked about that distributive. You're not really distributing, but sort of kind of. You need to remember that the numerator and the denominator both get that exponent of 4. All right, so let's look at some examples, and maybe after we do some examples, you'll be better off writing this rule in your own words. Okay, 4 sevenths to the second power. So this is the same thing, guys, as 4 to the second divided by 7 to the second. Okay, each, the numerator and the denominator, got that power. So 4 squared gives me 16, and 7 squared gives me 49. All right, so I have 16 divided by 49. Let's move on to the next problem. I have 3d squared over EF, all of that to the fourth power. So I'm going to write my numerator. All of that gets raised to the fourth power. I'm writing that in parentheses, and then all of my denominator gets raised to the fourth power. So right now, I need to take care of my multiplication property first, which when I see the numerator, I see that everything in the numerator must be raised to the fourth. These are old rules, guys, that we've learned. And then everything in my denominator gets raised to the fourth. So now when I clean this up a little bit, 3 to the fourth power is 81. And then I get d to the eighth. I multiply those exponents since it's a power to a power. And I'm going to divide that by e to the fourth, f to the fourth. Okay? Now, I want to look and see, are there any common bases that I can simplify? I have a d in the top, an e and an f in the bottom. I cannot do any more in this problem because I don't have any bases that are the same. So that would be my final answer. Okay, over here to this problem. 2x to the third divided by xy to the third, all of that squared. I'm going to start with my numerator. I'm going to square it, and then I have to square my denominator as well. So I'm going to write xy to the third, which is being squared. Whew, that's a lot. Okay, so in my numerator, I'm going to take each part, each factor in the 2x to the third and square it. So I take 2, and I'm going to square the 2. Then I take x to the third, and I'm going to square that, right? In the denominator, first thing I'm going to want to do here is work on the inside part of my parentheses first, and then I'm going to work out. So I need to go ahead and take care of this xy to the third power. That gives me x to the third, y to the third, right? And I'm going to square that, okay? So, if we finish this off, the top, I get 2 squared, which is 4. X to the third squared, that gives me x to the sixth. Multiply your exponents. In the denominator, I have a product of powers to a power here. So I have x to the third squared, which is x to the sixth. Multiply exponents. Y to the third is being squared. That's y to the sixth. Okay? Now I want to look to simplify this. I see I have an x to the sixth in the numerator that will cancel perfectly with that x to the sixth in the denominator. So what am I left with? 4 divided by y to the sixth. Okay? All right. I think I'm going to let you guys try this one on your own. So pause the video, and then quickly I'll work it out, and we'll see how you're doing. All right, welcome back, guys. See if you got this answer. A to the 5th, B to the 20th, divided by C to the 10th, D to the 15th. If you did, awesome job. Next one, last one, guys, negative power of a quotient. This is the same thing as what we just did, except for now our exponent's negative. Well, what do we do when we have a negative exponent? We bring whatever's in the numerator down to the denominator, whatever's in the denominator up to the numerator. So if I have 2/3 to the negative 4th power, how I'm going to address this negative exponent, guys, is I'm just going to completely flip my fraction, okay? I'm going to take the 2 that's in the numerator, and I'm going to put it in the denominator now, and I'm going to take the 3 that's in the denominator and move it up to the numerator. Flipping the position of those two numbers now allows me to have a positive 4 exponent, because I know that this would be 2 to the negative 4th divided by 3 to the negative 4th. Well, can't have negative exponents, so I have to bring the 2 to the negative 4th down, and I have to bring the 3 to the negative 4th up. Well, notice how that is the exact same problem as if I just take the reciprocal of my quotient and now have a positive exponent. So that's what you want to do when you have a negative exponent as your power in a quotient here. You want to take the reciprocal of the quotient and make your exponent positive. Make sure you're filling in your foldable with this stuff, guys. So let's do this example. I have 3/4 to the negative 3rd power. I'm going to take the reciprocal of the 3/4 and make that 4/3. And now I'm going to raise that to the positive 3rd. This is exactly like the last rule we just did, which tells me I'm going to do 4 to the 3rd divided by 3 to the 3rd. 4 to the 3rd gives me 64 divided by 9. All right. Next one. I have a negative exponent, so I'm going to take the reciprocal. I'm going to put the denominator in the numerator, and the numerator now goes in the denominator with a positive 2 exponent now. To finish simplifying this, I'm going to have y to the 3rd is being squared, and my denominator, 2x squared, is being squared. Remember, each numerator and denominator get that exponent. When I simplify this answer, I get y to the 6th, that's 3 times 2, and I get 2 squared times x squared being squared, right? Each factor in this product gets my 2 exponent. So I have y to the 6th divided by 4x to the 4th. You want to look at that, see if it can be simplified, but it cannot, so I'm going to stop. Same thing here, guys. Let's work this last problem out on your own and then see if you get the answer correct. We'll check back with each other. Okay, so there were multiple rules you had to incorporate here. I've shown my work. I end up getting a 9 in the top and a 9 on the bottom. Those things cancel each other. I had to multiply this s squared times this s squared to give me s to the 4th. So my final answer is t divided by s to the 4th. I know this was long, guys. Make sure your foldables all filled out, and I'll see you tomorrow.